Okay, let's take a look at matching equations of graphs. So let's start with three different equations, and I'll draw those in different colors. And here's a graph. So how do we figure out if any of these equations match up with the graph that's drawn in red on that Cartesian plane? Well, the easiest method is to do this. First step, find the x and the y-intercepts on the graph. So the x-intercept is here, that looks like negative 3, 0, and the y-intercept is here, that looks like 0 and down 6. X int, y int. And then the next step is to substitute those values into your choices. So I'll give myself a little bit more workroom here. And let's start first with y equals negative 2x minus 6. If I put negative 3 as my x value and 0 as my y value, do I get a true statement? Well, let's work this through. Two negatives become a positive, and it is true that 0 equals 0. So this point is on the green graph. That's all it tells us. We do also need to check the other intercept. So when x is 0 and y is negative 6, do I get a true statement? So we're just checking for essentially truth here. Is negative 6 equal to negative 6? Yes, just like 0 was equal to 0. So this graph also goes through that point, and if I connect those dots, you'll see I would get the red line. Let's erase that, and we'll try this with the blue graph. Okay, so let's substitute in negative 3 for my x value and 0 for my y value and see if I get negative 12. So, well, negative 12 plus 0, that certainly seems like it's a true statement. And so my blue graph goes through that point. Let's see if it goes through when x is 0 is y negative 6. And hopefully you can see 0 minus 12 is the same as minus 12, and it goes through that point as well. And likewise, if it goes through both points and it's a straight line, the blue graph works fine. Let's take a look at the black graph. So I substitute in negative 3 and 0 for my y, and I get negative 3 minus 0, and you can quite quickly see that this is false. Or you can say no, it doesn't work. And that means that negative 3, 0 isn't a point on the black equation or on the graph of the black equation. So it's not going to produce the same graph. I don't even need to go check the y-intercept. As soon as the x-intercept failed, it won't be the same picture. Now, why did the green and the blue graphs both work? Well, let's take a look at that in a little more detail. So here's those two graphs, and the first one's solved for y equals mx plus b, and the second one is in the form ax plus by equals c. And as I talked to you last day about, you can take these and rearrange them. So let's take the second one and rearrange it into y equals mx plus b. So we're basically just solving this one for y. So first thing is to subtract 4x on both sides. And that'll give me negative 4x minus 12, and then divide everything by positive 2. So both terms divide by positive 2, and now you'll notice that these two equations are actually the exact same equation. So if they're the same equation, they'll graph and make the same line. Okay, if we can match equations to graphs, we should be able to take graphs and figure out what their equations are. So let's see if we can do that. So there's our statement. If you have a graph, you can find an equation. And here's a graph. Is the equation y equals mx plus b. So in general, use that one. Because all you need to do is generate two values. You need to find the y-intercept. And the y-intercept is hopefully pretty easy to find. In this case, it's 0, 1. So the 1 is the b value. So I've already done quite a bit of the work. It's just a plus 1 on the end there. And then I need to find my slope. And the slope is the rise over the run between any 2 points on the graph. So I've already highlighted one point, which is the y-intercept. I just need to highlight another point and calculate the rise over the run. So the rise between these points is up that far, and then I run across this, and now it's just counting up 1, 2, 3, 4. So the rise is +4, and the run is to the right, 1, 2, 3, 4, 5. And I can double check that. I can take any 2 points, so these ones down here, and I can rise and I can run, and you see that you get the same values anywhere you go. In fact, any 2 points, so I could go up and I could go across like this. Well, that's not rise 4, that's actually rise 8. And it's not run 5, it's run 10. But 8 over 10 as a rise and a run is the same as 4 over 5. And we like to use lowest terms fractions. So my final solution for this one is y equals 4/5 x plus 1. That's a whole lot easier than trying to build a table of values and guess and check or use a strategy to see what the values, the changes are throughout a table of values. So this idea of slope is key. You spend at least 1 unit in grade 10 really exploring it, and if you take calculus in grade 12, you spend a couple of units in calculus talking about slopes.